Hi, and welcome to the latest webinar in 12D's training webinar series. My name is Lisa Stewart. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We love to run these webinars and record them for posting through our website, on YouTube and on Vimeo. The previous webinars from this training series, as well as the webinars from our Industry Solutions series and our What's Coming from 12D series, are all available on our YouTube channels if you missed those. During today's presentation, you'll be able to type your questions along the way using the webinar platform, and we'll answer as many as possible throughout the webinar. Then at the end, I'll read out some of your questions to the presenter for his insights if there's time. Today's webinar, What's New in 12D Track, will be presented by Jason Knox, who has 17 years of experience leveraging the power of 12D model. His background in civil design and software development has encompassed rail, mining, LNG, and renewable energy sectors. Jason's training initiatives equip individuals and teams with the skills needed to utilize the software effectively. Jason will demonstrate how to generate best fit geometry from surveyed pickups, visualize offset calculations in plan, section, and custom reports, apply dual gauge cant on several vehicles while highlighting non-compliant design criteria, and generate stunning 3D trimesh extrusions using 12D's new track tools. Over to you, Jason.
Thanks, Lisa. We're going to look at the Calculate Centerline panel, how to create a survey centerline, and how to generate a best fit superalignment. We'll also look at the Calculate SLO panel, visualizing slew and lift values in a plan or section, and using style sheets to generate custom offset reports. The next panel we'll look at is the Calculate Cant panel, how to apply dual gauge cant and curve compensation settings, applying speed restrictions, highlighting non-compliant values from design criteria, and how to generate rails and reports. Finally, we'll look at the section to Snippet panel. This is to create 3D trimesh extrusions from a polygon, and we'll use this to generate rails, clips, sleepers, ballast, and a tunnel. This is the process for creating a best fit alignment. So I'll just add the design track menu, and I'll turn the track toolbar on as well. So I'm going to bring in a survey, file input 12D, selecting the file and selecting a map file, read, and just here I've got the yellow rail strings here. So I'm going to use the Calculate Centerline option on the track menu. This is it on the toolbar. I'm going to use the rail default settings, and I'm going to use a function name, selecting the left and the right string. Under properties, I can turn on various options here. So I'll just clear this first column, and I'm just going to add the regression spiral centerline element. So at this point, I'll just press process. So there's a number of views have been created here. I'm just going to place this one. So this is a 10 of the existing cant, which can be used for plotting and other things. There's a radius, once again for long section plots or other things like that. There's the regression tolerance, so I'll just have that one there. And there's a regression spiral here. So the settings under the regression tab, so we have spiral tolerance of 7 has been applied. So anything in this regression spiral view above 7 will turn that into a spiral. There's a noise filter here. If you've got perfect geometry that you're recreating, you might use 1, but you can see with we can increase that to 5 in this case for a noise filter, and that cleans up the this regression tolerance diagram a lot better. So you can see there's bands of colors here. If I just turn on the survey view, we can see that some colors have been applied in the regression colors tick box here. And we've got red is the tangent or the straight part. We've got cyan is the spiral or transition, and we've got green is the curve or arcs. So there is an alternative method here as well. If I tick that tick box on and reprocess this, and just take note of how that looks at the moment. So the spirals go right down to the bottom now and all the way to the top. So that's just a different method for calculating the extents of each curve, spiral and tangent. Once we're happy with those settings, we can create a best fit super alignment. So just clicking on the button for generate super alignment, and then we can use a string editor or an F6, pick and accept on the super alignment. So the on the 5th column, second from the bottom, the horizontal regression has been filled in. So this is the regression points automatically filled in, and you can tick on or off boxes. Any of the outliers, you can remove them from the data set. The regression parts, this has been filled in, and in the output window you've also got what it's identified as the start and end of each segment. So what we'll do here, we've got a compound curve here because you can see it's an M shape. So if I just turn on the road features, you can see there's a road through here, a level crossing in the middle of the curve. So I'm going to insert above and just put another arc in here. Right click for the arc. So the first arc will be going up to the 91 point. The in the properties for the center line, there is a vertex indices has been selected here, and that's turned on. You can also use the toggle for the vertex indices, and you can use an F2 string inquire and change this to a 12D inquire, and then we can select a point, and at the bottom there's an index number. So there's 3 ways of getting the vertex index numbers. So this one will change to 139, and it will be going from the 92 point. A0005 arc, we're going to change that to 91, and we'll set that. The only other thing we need to do for this is to now add this part that we've just created into our part editor. So the 5th column here. And I'm just going to copy the 5th part here, A0005, copy and paste. Select the use tick box up the top, selecting A0006, set down the bottom left. And then I'm just going to add in this case, a free line, but in other cases you may want to have a free transition. But in this case, I'm just going to add a free line through that level crossing. And that's the best fit geometry done. The Calculate SLO panel is located on the Design Track menu. It can also be selected from the second button on the toolbar, the track toolbar. So I'm just going to enter a function name. I'm going to select load defaults. This will populate a lot of these fields. And I'll select the design superalignment and the surveyed centerline. Under changes, there's different options. If you want to have an interval, the default is just a surveyed centerline vertice to report out. Under properties, there's some different options. For the SLO, this is the horizontal offset between the surveyed centerline and the design centerline, and it uses a depth range file, which is optional. So a depth range file, there is one that comes with 12D in the library, and you can create a new one if you want to change any of the values there and then enter it here. The standard report can be filled in here if I process that and then open the file. So this is the standard report. This can be customized with a style sheet here. The element generated in the properties panel here can be viewed in a plan view or in a long section view. If I just change the exaggeration, so you can see the areas that may be outside of the extents, and you may want to adjust those either from plan or section. To report custom offsets, I'll just generate a draped alignment. So I'm going to select the design superalignment, selecting the existing survey, and I'm going to just put this onto a model survey surface formation level and select drape. I'm also going to turn on the survey railway features and zoom in at a railway signal here. So if I select F8 to open the string attributes, there's currently no vertex attributes for these elements. So I'm going to use a attribute manipulator file. If I just select the railway signals, filter it to anything named RWSIG, and then apply an attribute manipulator file. I'll just open that so you can see how that's been set up. But essentially it's just going to grab the vertex point ID, assign that to an attribute, concatenate that into another attribute, and then also create a level attribute. So if I run this and then refresh the vertex attributes, I've now got a signal number, a name, and a level that I can use in the Calculate SLO Offsets panel. So I'm just going to enter some values here. We're going to first have the formation depth. This is going to be of type vertical, so a vertical distance between the design superalignment and this draped formation level model, and I'm just going to select the formation level. I'm also going to apply negation, so times in everything by -1. For the formation level, this one will be a source Z, so it'll be picking up the Z levels of the formation level. There is an option here that I can create elements here, whether it be centerline, tin, trimesh as well. That is optional. So in this case, we're just going to be adding this to a report. The next one is going to be the signal attributes. So I'm going to select vertex attributes, I'm just going to use the middle click here to select the source and model name. So I'm going to filter it down to just the railway signals. And I'm also going to select yes for the vertex changes. So this will include in the report any of the railway signals will be added as a new row in the report. And I'm just going to change the changes here. Instead of every surveyed centerline vertice, I'm going to put a 500 meter interval. So we'll have 500 meter changes plus these railway signals. And the last one is just a signal, horizontal distance between the railway signal and the design superalignment. And I'm just going to copy that down to there. So these report refs names, they are going to be what we use in the style sheet. So if I go to the style sheet, I've created one before, and what you can do is just copy the one from the library. There's a calculate SLO HTML or a CSV option in there, and you can copy that and then modify it. But if I just open this file, and we'll go back to the offsets here. So I've got the report ref. This will be whatever it's named in the style sheet. So I've got formation depth, links up with formation depth. We've got formation level is just here. We've got the signal is just here. And for the signal attributes, the vertex attributes, so I've got signal ATT, and so I've got that here. And then I've put an underscore with the name of the attribute. So that's the name of the attribute there, railway signal 4900. And then I've got signal at underscore level, so it'll be picking up that level, whatever's in the vertex attributes. So if I process this report now and open that, so this is the report that you can get. So every 500 meters, I've got an interval, and then I've also got the custom railway signals here that have been added. So those custom changes. If I want to add any other fields, these are the standard fields. So if I wanted to turn on the number and maybe the change equalities, I can do that, save, and then it's just a matter of selecting process again, and then opening up the report and pressing refresh. So I've now added the number and the equality to the report columns. The only other thing with the style sheet is just to change it in two places. So you've got the report ref here will coincide with there, and just lower down here you would actually put the name of the column. So whatever you want to name it in the report, you would put that further down the bottom there. And there's other options for turning the logo on and off, and other things at the top here that can be turned on and off. To apply cant to the design superalignment, we select the calculate cant from the design track menu. It's also the third option in the toolbar. Selecting the load defaults button, selecting the design superalignment, typing in a function name, and then editing the network specifications. So a curve compensation calculation can be done. In this particular case, it's going to be this calculation and that constant. Under the gauge, we can select a rail gauge from the list here. So if I want standard gauge as the primary rail gauge, we can also have dual gauge selected and select narrow gauge for the secondary gauge there. And there's a common rail location option at the bottom. Under the vehicles tab, we can name various vehicles. Select which type of gauge they're using. So this first one is using the primary standard gauge, and apply a speed default speed. The next one could be a freight on the narrow gauge, so selecting the secondary gauge, which corresponds with this, and then applying a different speed for that one. So that's the first file that we've set up for the network specs. For posted speed limits, we can edit this file. So we can select a vehicle, select the range, and then select a speed. We can select a different vehicle and apply a different speed to that vehicle in the same range. And we can also apply a speed limit to all vehicles and then select a different speed for that. The last one is the design requirements. This one I've prepared earlier, but you'll set this up with whichever standards you're working to. And there's different options here under vertical, horizontal, or the cant related requirements. Apply it to any of the vehicles, and then there's a desirable minimum and maximum and an absolute minimum and maximum. Under the custom requirements tab, these can be applied to different vehicles. You can select desirable absolute, minimum and maximum, horizontal or vertical plane, and then whether it's a tangent length, transition or curve length, and then a curve radius. And then these ones are set up where this one's set for half of the vehicle speed, this one's set to the full vehicle speed. So these design requirements can be set up however you need. And then when you open up the cant editor and select recalc and write up the top left, this will highlight in yellow any areas which are outside of the desirable limits, and red if it's outside of the maximum or absolute limits. So you can see this first one, we're outside of the absolute limits. So we can adjust the speed on this first curve. So this is now saying that the optimum cant is 81.9 millimeters. So we can change that to round it down to 80 millimeters. If we write that file, and then we can select a different vehicle. So we've applied 80 mil on the standard gauge. The equivalent narrow gauge cant is 59 millimeters, and we can see it's outside of the cant deficiency absolute limits here, so we'll need to reduce the speed for this one as well. If we are applying different speeds, we can just update our posted speed limits and just change these speeds in here. Write the file, recalc the cant, and then all of those different vehicles have been updated with the new speeds. Under the vertical compliance button, we've got different design criteria that may be outside of the limits as well, and you can change vehicles to check how that affects the different vehicles. Some of the notable things in here are the curve compensated grade and things like changing grade and other things that you may need to be checking. Under the properties tab, we can generate different types of elements that appear in a plan view or as a tin that can be added to like a long section plot PPF. If we just want to display the design speed as a center line in our design view, we can process that. So that's how that works. We can also have rails generated through this panel. So we'll have the primary and the secondary gauge. So that shows up those in our view now. And we can also have a custom gauge file. So if we want to do gauge widening on the primary, recalc, and then just put in the new values for the rail gauge. So 1438 through this first curve, write that file, and then this can be added just here under custom gauge. There's various reports that can be generated. So the first report is just the cant editor, looks similar to the cant editor. So if I process that and then open this one, that's what that report looks like, and it shows each vehicle. Some of the other reports that can be generated include a rails report, a speed report, vertical compliance, and an interval report at a specified interval. To generate the rails, sleepers and ballast, we can use the section to snippet panel found on the track menu, and it is located here on the toolbar. So first of all, I'll bring in some polygons. If we first want to create a rail, we can select the section. These polygons are just drawn as straight lines, and they're just a closed polygon. We can give this a name. We could save these into the user lib so that they're available to other projects. And then for this one, I'll be using on grade, all points on grade, and trimesh element. We can go to the defaults just to select our rail strings that were generated in the calculate cant panel. And then we just process that. Next, we'll have to create a apply MTF. So I'm going to select the design centerline. We can turn off the tins and models and stuff and open up the MTF. Selecting open. Once again, we'll just select that center line. So we modified left, double click to add a snippet, navigate to the user lib, select the rails that we've just generated in here, and we've now got these options. Those settings are fine, and I'm just going to left click, right click, copy, modify the right side, right click and paste. Okay, on both of them, I'll click on this auto recalc and save the file, apply the file, and then these can be turned on to a perspective view. Trimesh rail. And these can be added to a section view as well. So that's the rails there. Right, the next one is a sub-ballast capping. Selecting the sub-ballast capping layer there. This one will not be on grade, so it's not affected by the rails and doesn't take into account cant. It's just going to be a straight extrude the whole way, so we can process that one. This one can be added to the right side, so modify right, add in a new row, selecting a snippet, selecting the new SBC snippet that we have, changing settings if we need to, and then applying that. And we can turn that one on. A tunnel can be created. So selecting the tunnel, typing in tunnel, this one can be a one element, and we'll process that. Then if we add this to the right side, snippet, selecting the tunnel, specifying a length, so we could say 100 meters from the start. There's no option for end chainage for this one because it's dictated from the start with the segment length. And then if we just copy this one to the left side, pasting that one in there, and then add in the tunnel, and adding it to this view as well. So if we want upright bits added to the tunnel, we can select that. Add the uprights to the name. This will be set up as many, and we can change the defaults for this, the length being 250 mil, 5.25 distance between, and then we process, adding that to the left and right side, selecting a snippet, and we can just say the first 100 meters. Copying, pasting to the left side. The next thing could be the sleepers. Selecting the sleeper. This one will be set up as many, and we'll be translating the base point up, and all points will be on grade so that these follow what the cant, so it takes into account the cant. We just have to change the segment length and distance between, and then they can be added to the right side. Snippet, selecting the user lib, sleepers, changing any of those settings. I'm just going to make this go for the first 100 meters only and apply that. Next thing we could do is the clips around the rails. Selecting the clips. With different settings. These are just default settings that come up, but they can be changed for each one here. Selecting the clips. Setting an extension reference at the start. And just going for the first 100 meters. And I'll copy this one to the left side as well. Finally, the ballast. This one's a bit more difficult to set up. So typing in ballast, selecting the ballast. This one, not every point's going to be on grade for this one because we're going to be running a batter from this point down to wherever it intersects the top of formation. So we're going to change the manipulate points to vertex attributes for this one so that we can specify every point with something different. So under the vertex attributes, I'm just going to select the grade for translate and then generate vertex attributes. So if I F8, select the ballast, there's currently no vertex attributes. If I select the Generate Vertex Attributes button and refresh, these vertex attributes have now been generated. And we can go ahead and fill them in. So the first vertex, which is up the top left here, that one's okay, left as is. The second vertex, we're going to change this one to grade 10. Just typing that in, and it's going to be a 0 fill so that it translates directly down until it hits the top of formation. So I'm just going to apply that one. The third one is going to be set as a 10, and we're going to be coming up off the fourth vertex, which is this top right hand shoulder. And we'll be coming down at 1 and 1.5. So type in 1.5 for that. The last one, vertex 4 at the top here, is just going to be on grade. So it will be matching the same grade as the cant. Okay, now that I've applied those, I can process the ballast snippet. And then it's just a process of adding that to the left and the right side, snippet, ballast, and we just have to select an interface tin here. So the top of the formation should be selected here. And something I've missed was to just take the many off that and just reprocess that. So once again, that's how it should be set up. So if you just take the segment longitudinally, remove that, and the ballast will just continue through. So I'm going to copy this one to the left side, paste that in, apply it, and I'll just add that to each of the views. and I can just move that one to the back. So when we go around a curve, you can see how both the sleepers, the rails, the clips, and the ballast, the top of the ballast, are all on grade going around curves to match the cant. Back to you, Lisa.
Thanks, Jason. We've had a couple of questions through, so I might just share a couple of those live. So we had one from Jen in Melbourne asking, you mentioned that the tins produced from centerline and other panels could be used for plotting. What did you mean by that?
Yep, so hopefully you can see the screen. So if you've calculated cant, for example, and you've selected like a design speed as a tin element, yeah, so that can be added into like a plan profile. So it's the sort of thing where you need to have an extra row with some values in it. You could add that into your PPF. So something like this with that design cant speed, yeah, that can be added into here. So something like that would, yeah, give you like a design speed or something like that. So hopefully that answers the question.
Yeah, great. Okay. And John in Brisbane said, does 12D offer any training specifically for track? And actually, I think someone else was asking that too. So hopefully we'll have a good answer for that.
Yeah, so if you jump onto civilandsurveying.com, there's under the design section. So this is all of our training that we offer. And under design, we've got just at the bottom, there's a track course coming up. So you can register for that one or for the next one. So they'll be advertised. We usually do them once every couple of months at the moment. So yeah.
Fabulous. Yeah, here's one we prepared earlier. That's wonderful. And I think we'll have no training just until after the Tech Forum.
Yeah.
So Tech Forum will be 28th to 30th of July in Brisbane. So I hope everyone here today has got their tickets for that, because it is starting to get close to selling out. And after that, and these sessions will happen, and then Tech Forum, and then we'll get back to regular programming from there. And I think I'll just do one more question live today. Thanks. So David in Perth would like to know, well, he's just said, what's coming next for 12D track?
Okay. Yeah, so I'm sort of working on some skewed culverts at the moment. So the idea is that you have your culvert center lines that you can add. Still working on this software. So, but you can sort of set up your different types of culverts here, and then labeling defaults, and you can have the same sort of design requirements as the cant editor. And then in the culvert editor, we can recalc, and there's an auto redesign feature here, so you can have your culvert IDs updated automatically. So this one's set to chainage, or you can have incremental, so we can process that. And you can see that's updated all of our culvert IDs. And then you can set these. So we've got a barrel length, which gets applied to these reinforced concrete box culverts. So if I try that, and then select the auto redesign to process that, so that can automatically set the barrel length to whatever multiple was set there. So yeah, there's a few things going on, and more things to come. So that's what I'm currently working on. But yeah, if we process that, we can get those in a 3D view here. And you've got your rock protection and labeling, everything's all sort of included with this tool, and different reports.
Fabulous. That looks like it's all going to be great.
Yeah,
Well,
still working through that one.
Yeah. So yes, I think that'll be enough for our live questions today. Sorry to anyone we didn't get to live, but I'll email those through to Jason shortly. And the recording of today's webinar, a couple of people were asking about that too. So that's going to be available in coming days through the webinars page on our website. And it'll be on our 12D Model YouTube channel, and we'll have a Vimeo link as well if people need it. I'm also going to email the link to everybody who's registered for today, and keep an eye on our emails and social media for details of our upcoming webinars. I think we're going to have Lee do one about the tech forum in the next few weeks as well, just to sort of let everyone know what's going to be happening at that. And I think, yeah, I'm just going to pop some contact details on the screen in case anyone needs to contact us in the meantime. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.